Welcome once again to another module of Advanced R. As you can understand, in this module we are going to continue the discussion what we had started in the previous module. Here we are continuing the discussion of building package in R, and in the previous module we have come across different steps that are needed to build a package in R. The details of the folders where the necessary things, necessary files should be submitted, and lots of things. In this module we are continuing the discussion again. We will give you some recapitulatory ideas, and here we will start with some ideas like how to finally edit the file and how to submit them to CRAN. Then again we will discuss something about how we can use this with the help of other languages, and also some examples will be there in order to demonstrate with finally. Some of the things regarding the compilation of all these things will be there, and some concluding remarks will be there in order to give you the ideas accurately. So, let us stop here and let us see what is there in this module. So, in this module we are going to learn about editing files and submitting to CRAN, use of other languages, and compiling package and some conclusions. So, here comes the idea of the second part of building package in R. Now, you know that the root folder of the package contains at least a description file and a namespace file. So, revise those concepts once again. Description is a package, contains the package information including dependencies. Namespace contains list of functions exposed to end user and functions imported from other packages. And the news contains what has been updated in each version, and the license is the copyright information, and readme, as you can guess, it's the basic description of the package. So, go back to the my package package that we had made. Edit it to get rid of the text that is not in these sections. You can also add some simple descriptions and remove some of the optional elements. Next, edit all the files for each function and the help files for the data. Next, edit the other files, example that had been given here like f.rd, g.rd, sample df.rd, and many more. Now, you have two options to build your package. You can build the package for CRAN, or you can build for yourself and for other Windows users. When you are building for CRAN, build and check. You have to do this because you have to assure that you passed all the CRAN tests. Some kinds of tests are there, so you need to pass all these kinds of tests. The output is a tar.gz file which you will upload to CRAN. Then the process will be repeated and your source will be used to build a OSX binary and a Windows binary. Windows binaries are present in zip files. So, write all documents and then pass all CRAN checks. You might be familiar with all these kinds of files, because whenever you try to download some new package in your computer, then these kinds of options are there. So, you might have been familiar with all these kinds of options, all these kinds of files. Now, the next thing is you need to build the package again for Windows and produce a zip binary. Now, building packages require going to the command prompt and using commands like rcmd check, rcmd build, and rcmd install. These are some technical issues that you need to know or need to memorize. In Windows, it is rcmd instead of rcmd. You may see this from here as well. all the command prompts must be in the proper directory. Now, this process can be done from within the R console. So, a big thank to Hadley Wickham, who had made all these things easier, because previously it's really a great issue to build your own packages, but now it's not. So, first make sure a package is properly documented by calling document. The first argument will be the path to the root folder of the package. You know what the root folder is? So, do this with that folder. If the current working directory is similar to the root folder, then no arguments are even needed. It is true for all the dev tools functions, or you may call it dev tools. We have discussed things regarding this previously as well. Now, build all the necessary .rd files, the namespace file and the description file. Remember, all these kinds of files, the things regarding all these kinds of files have been discussed previously. So, by now you know what these kinds of functions are. Now, after submission, CRAN will send you an email and ask you to confirm that the package was uploaded by the maintainer. So, when you are replying to CRAN's email, make sure that the subject line is of the format CRAN upload, package name, then package version. Remember that the name of the package is case sensitive. So, you should always remember this thing. Actually, we have remembered this thing as well when we want to download some packages from CRAN. We want to search some packages from CRAN as well. So, be careful about the name of the package, because it must match with the name of the package in the description file. So, you need to check that once again in this step. You can write anything in the body of the message. There are no particular guidelines, there are no particular formats as well. But one thing that makes sure is to be polite while writing this email, and don't forget to say thank you, because the CRAN team puts in an incredible amount of effort in spite of not getting paid. Always remember that. Sometimes R code is not enough to build a package. In that case, you should use a compiled language. You can use the languages like C, C++, Fortran as well. Fortran is used for calling a function written in Fortran. It might be the case that you have written a function in Fortran. In this case, what will we do? We will do these things. Call is used for calling C and C++ functions. Again, if the code has been written in C and C++, then this will help. So, you must have knowledge in Fortran or C or C++ as well to use these languages. I am sure you might have some basic languages regarding this, some basic ideas, some basic knowledge regarding these languages. So, you can use this by now. Now, RCPP package is a great package for integrating C++ code for building package. We have come across this package when we were discussing about simulation in R. That helps us for integrating C++ code for building packages. So, thanks to these two men for making it so much easier. It handles a lot of necessity to make C++ functions which are called from R. Now, a number of tools are necessary for working with C++ code. First, you need a proper C++ compiler. In this case, it is better to use USC GCC. Linux users should already have GCC installed. Mac users need to install Xcode and might have to manually select G++. It is easy for Windows users to get started with C++ code. thanks to art tools developed by Brian Ripley and Duncan Murdoch to make it so much easier for Windows users. It provides all necessary development tools including GCC and Make. The proper version can be downloaded from the link which has been given here, and after downloading this you can install it easily. So, after downloading from the link mentioned in the previous slide, install GCC as I have told you. If you build packages from within R using DEV tools and RStudio, then the location of GCC will be determined from the operating system's register. A Latex distribution is needed for building package help document. So, here comes some of the ideas regarding compiling packages. Source CPP makes ad hoc C++ compilation easy. When you are writing C++ function, it should be saved in a .cpp file so that it can be sourced using source CPP, while automatically compiles the code and creates a new R function with the same name. To execute the C++ function, a different strategy is needed for building R packages using C++ code. The C++ code is usually put in a .cpp file inside the src folder. So, these are some of the technical issues, and you just need to memorize this, or you need to know what these things are. Any functions will be converted into end user facing R functions when the package is built using build or DEV tools. Any R Oxygen 2 documentation will be used to document the resulting R function, and vector add function should be written using R Oxygen 2. Now, RCPP compiles the code and creates a new .r file in the R folder along with all the R codes. Any functions which are not preceded by this thing RCPP export are called from within other C++ functions, but not from R by calling .call. To execute C++ functions, a package's namespace must contain this package, whose name is use dyn lib. This is the name of the package. So, this can be done by putting the @use dyn-lib package name tag in any of the R Oxygen 2 blocks. In addition, if a package uses RCPP, the description file must list RCPP in both the linking to and depends fields, because these are all the dependencies which your newly invented package must have. The src folder of the package must contain makeverse and makeverse.win files to help the compilation. Building a package is a great way to make code portable between projects. Also, it is a great way to share it with other people, as I have told you earlier. It's really a great way to share your ideas, share your newly invented theory with anybody else. A package with R code only requires working functions. These working functions should pass the cran check using proper help files. These help files further can be easily built by including R Oxygen 2 documentation and calling document. So, as you can see from this module, we have come across lots of ideas regarding building a package in R. In the previous module, we had come across the steps regarding building a package in R, but here we come to know how we can edit a file and finally we can submit it to R, how we can use it with the help of other languages as well, and we also know how we can compile a thing, and also some conclusion parts are there. So, we are stopping the discussion here and we are concentrating on the next module which is based on totally a new topic. So, let us stop here and let us see what is there in the next module.